All right. Good morning. We're going to be on the 1C notes, and what I want to do is I actually want to show you the Geogebra website because I'm going to use this to sort of prove some of the stuff here. Okay. So the Geogebra website is linked up on Google Classroom, geogebra.org/geometry. Okay. And so here's the website. It kind of looks like this. All right. So we have our basic tools here. If we want to hit the more button, I would just keep hitting the more button. Um, until we see sort of all of our tools, and you'll see you're going to get a boatload of tools in here that we can use that are actually pretty cool. Okay. Um, so what's kind of cool is we can make a line segment here, and then we can measure the distance. If we want to hit the distance, we could just click the 2 points. It will give us the length of the segment there, AB, and we can move points if we want to, and then we could see that, the distance moves with us. So it's a very interactive thing, and it's very fluid. It's really kind of cool how it all sort of works. Okay, and then whenever we want to clear the screen, just hit clear all, don't save, and there's all this kind of stuff in here. If you go to Google Classroom, we did the constructions from 1B on the MathPad website. You can also do constructions on GeoGebra just using the circles, and there's also videos that are in there if you wanted to do GeoGebra constructions there. And I'm going to show you guys a few shortcuts and some cool stuff that GeoGebra kind of helps prove. Okay, and that's going to be part of our 1C notes. All right. So the first rule on our 1C notes here: if a point is on the perpendicular bisector of a segment, it is blank from the blank of the bisected segment. Okay, and what's going to happen here is I want to show you guys this. So let's say we make a line segment right here. Okay, so I have a segment AB. All right, now if I wanted to do a perpendicular bisector, I could do my circles and arcs and make a perpendicular bisector of all that. Okay, or I can go to my construct tool right here. I'll click perpendicular bisector, and it'll say, select 2 points or one segment. So I'm going to click point A and point B, all right, and click on them, click point A and click point B, and there's my perpendicular bisector. It's already kind of done for me, which is really kind of cool. Okay, and so now what I'm going to do is I'm going to hit this point button right here, okay, and I'm going to hover my mouse to where it has a little hand thing there, and I'm gonna click. Okay, so it's gonna put point C. So point C is now gonna be on the perpendicular bisector. I can sort of toggle it up and down along that line, which is kind of cool. Okay, now we don't have to, but we could do a segment from C to A and C to B if we want to. Okay, so I can do a segment from C to A and a segment from C to B. Okay. And another thing I'm going to do is I'm going to hit this point button right here. I'm going to hover right over where they intersect. Whoops. Right where they intersect, I'm going to put a point D. Okay. And it'll be nice and gray, and you'll see it'll fit perfectly on that line segment right there. Okay. Now what I'm going to do is I'm going to measure distance and length. So from A to D, 5.4, D to B, 5.4, which it should, because again, this CD is a perpendicular line sector of AB. I'm also going to measure points from C to A, 8.5, and the distance from C to B, 8.5. Okay. Whoa, would you look at that? Okay. So the distance from C to A is the same as the distance from C to B. Now, as I say, we move point C around. Okay. If I move point C, those distances move with it, and we can kind of see something here. 9.1, 9.1. Move it a little bit more. 6.3, 6.3. Move it again. 14, 14. Move it again. 7.2, 7.2. Move it again. 5.5, 5.5. Oh, that's pretty interesting. Okay. So from this, we kind of learn that, coming back to the notes here, if a point is on the perpendicular bisector of a segment, it is what we call equidistant. Okay. Equidistant. Now my writing is not very good on this thing here, but it's equidistant from the endpoints of the bisected segment. Okay, so equidistant, I mean, it's pretty self-explanatory. Equi, like equal. Okay, and distance. Okay, so if a point is on the perpendicular bisector of a segment, it is equidistant from the endpoints. Okay, so coming back to our thing here, point C, okay, is on the perpendicular bisector. Okay, it's on this up and down line right here. Okay, and anywhere on the perpendicular bisector is going to be equidistant to point A and to point B. Okay, and another thing that's kind of cool with this, all right, is let's say I wanted to, delete this line segment and delete this line segment right there. Okay, and delete that and delete that. Even if I didn't want to do those line segments right there, okay, I could still do the distance. Okay, where's that distance or length right here? From A to C and B to C, okay? And even as I move point C, those distances will move along with it. Okay, so it's kind of a cool little interactive tool right here where you can kind of mess around with it and see how this stuff kind of works. So as long as point C is on the perpendicular bisector, it's going to be equidistant from the two endpoints of the segment that is bisected. Okay, it's exactly what the notes say. Okay, so now I'm going to just delete everything here. And where was I? Okay. All right. Next, if we have a point on an angle bisector, okay, a point on an angle bisector, and this is something that we're going to look at more, I believe, in unit 4 or 5, one of those two units, in regards to triangles. But we're doing constructions here, so I figured we would just sort of talk about it a little bit now. Okay. So let's say we create an angle. All right. So I'm going to make, I'm going to do the segment thing right here. I'm just going to go click, click. Okay, and then click from B to C. So we have this angle ABC. All right. Well, again, if we wanted to make an angle bisector, we could do the circles and the arcs and all that just using the circle thing. Again, it's linked up on Google Classroom, or we can do the angle bisector tool. So I'm going to click the angle bisector tool, right? And I'm just going to click A, B, C. Okay, and now I have this big old angle bisector right here. Okay, now I'm not going to do the distance thing right now. Well, I'm not going to draw the line segment up right now. I'm going to put a point on here. So, all right, so I'm going to put a point D. So point D is along the angle bisector right here. Okay. Now, I'm going to find the distance between point D and this line and point D and this line. Okay. And so we can do that. We can find a distance between a point and a line. So if I hit point D and I hit that point line, so it just creates a little F right there to delineate the line F. So the distance from D to line F is going to be 3.4, and the distance from D to this line, which I'm going to call G, is also 3.4. Okay, so here, as I move point D up and down the angle bisector, we notice something. Oh, wait, point D has the same distance to this ray as it does to this ray. Okay, point D is on the angle bisector. It is equidistant to the two rays. Okay, so coming back to our notes, so we talked about the perpendicular bisector of a segment. Okay, the point being on the perpendicular bisector is equidistant to the endpoints. Okay, well, what's going to happen here if a point is on the angle bisector? Okay, if an angle then is equidistant. Okay, at 90 degrees to the rays and sides of the angle. Okay, and we didn't talk about the 90 degrees thing, but just as a side note here, whenever we measure a distance from a line to a point, it needs to be measured at 90 degrees from the line. Okay, so it's almost like you're like when you're measuring your height. Okay, if this is the floor, right? All right, you need to stand straight up, at 90 degrees, right? Because a 90-degree angle from the line to that point wherever your height is, okay, that's going to be your height. You know what I mean? You need to stand at 90 degrees. Well, the same sort of applies here, okay? So if I were to do a line, now let's say I do this perpendicular line. Okay, perpendicular line. I'm going to click point D, okay, and perpendicular there, and point D and perpendicular there, right? And so now what we have is I'm going to make a point DE, DF, okay? I'm going to delete all this. Whoops, didn't want to do that. Okay, so I have the distance from DE. So this line ED right here, it is perpendicular to this ray, and it hits point D. This line DF right here is perpendicular to this ray, hits point D. Okay, so at a 90-degree angle, measure my distance from D to E, 2.7, D to F, 2.7. Okay, so as I move point D, okay, as you see, as I made those line segments, these perpendicular lines that kind of move with it, right? So D to E and D to F have the same measurement. Okay, it's really kind of cool. DE, DF, same measurement. Okay, so kind of another rule that we have with angle bisectors here. Okay, and hopefully you have a little bit of time on Geogebra. I'd like you to sort of play around with this a little bit on your own and sort of familiarize yourself with the app and sort of see what you can do there. And that's that. A couple more things I want to discuss on this. And the last two things we're going to discuss on Geogebra sort of go, in between with the rest of the 1C notes. Okay, so I'm going to clear all this stuff. We go to the back of the 1C notes. All right, let's see. I'm going to jump down here to rules for betweenness. Okay, so line segments. Okay, so simply put, if we have a line segment AB, if point C is in between A and B, then what's going to happen is AC plus CB is going to equal to AB. Okay, so AC plus CB is equal to AB. We can go in Geogebra and we'll look at this. It's a very, very simple concept here. Okay, so let's say we make a segment AB. Okay, and let's measure this segment. So distance of this is the length of AB. Hit that 13.4, and I can hit this move thing and move that number kind of out of the way if I need to. Okay, now I'm going to put a point C here somewhere. Okay, so point C is up there. Now I'm just going to do the distance from A to C and B to C. Okay, and what do we have? Well, okay, from A to C is 6.7. B to C is 9.4. If I were to add AC plus BC, okay, 6.7 plus 9.4, that's going to be 16.1. That's not equal to 13.4. Okay, point C is not in between A and B. Okay, remember, if we have a line segment AB, if point C is between A and B, then AC plus CB equals AB. Okay, well then they're not, so that's not the case. So what we got to do is if point C was on AB, so let's say we're to move point C and put it on AB. Okay, now point C is on AB, so we have 4.8, 8.6. Okay, well, 4.8 plus 8.6 is equal to 13.4. C is now in between A and B. Okay, 4.8 plus 8.6 is equal to 13.4. Okay, because point C is in between those 2 points. Okay, pretty simple stuff. It's a pretty simple concept, but what I like about Geogebra is that it kind of is interactive and you can move it around a little bit. I could even stretch this line segment out and make this thing a little bigger, make AB a little bit bigger, and these numbers sort of change around as well. It's really kind of cool to sort of move stuff around and see that. Okay. And the same thing is going to happen with angles. So if I clear this thing here, don't save. Okay. And so the last part of these Unit 1 notes, okay, if we have an angle ABC and ray BD and point D is in between points A and C, okay, then the measure of angle ABD plus the measure of angle BDC is going to be equal to the measure of angle ABC. Okay, if the ray BD is in between, okay, points A and C. Okay, so what's going to happen here is, let's go to our GeoGebra. Now we're going to make, okay, angle ABC. So click A, click B, and then click B, click C. Here's our angle. Now we're going to make a ray. BD, just like that. Okay. All right. So now this ray is in between, okay, these two points, okay, A and C. And we can measure the angle. So let's say we want to go here, measure angle. Okay, so if I want to do angle, I'll measure angle A to B to D. And it sort of comes down here, so it's 24.2. So we kind of just hit the move button to move it up, okay? So ABD is 24.2. Measure the next angle of DBC, 30.6. Okay, and if we want to do the whole angle, we'll go ABC. All right, and that's going to be 54.9. Okay, so these two add up. I mean, it's a little bit of a rounding error right here. 24.2 plus 30.6 is equal to 54.8, just a rounding error right here. But we should see that, this little angle plus that little angle are going to add up to that whole angle. Okay, and I can go to the move function here. I can move point A around here, So here I made it a nice even 93-degree angle. So this whole big angle here is 93 degrees, right? And we've got 62.4 is this angle ABD, and 30.6 is this DBC. Okay, and they add up to the whole angle of 93 degrees. Okay, and we can move point D around if we want to, and we still have two numbers that are going to add up to 93. Okay, and so that's it from the 1C notes. I would like you guys to maybe play around with this a little bit, and use a GeoGebra app and try some of the stuff out for yourself and just familiarize yourself with it for a little bit. And then once you have that, then we have a bunch of algebra problems at the end of 1C, to where we're going to solve for the missing variables using basically these two rules right here. Okay, this line segments and angles. So segment addition and angle addition down there, just to sort of sharpen our algebra skills and make sure we're good. All right, we have time in class, so if you have any questions, please let me know. And you guys have a great day.